Today I'm going to show this coil here in a high RPM test. The RPM are going to be around 2800. I'm using a test rotor with 24 poles. It has 24 magnets on it. It is made of wood. The magnets are a little bit smaller than in previous videos, so the output of this coil is a little bit lower. I'm running the system on 28.5, but when it's up to speed it will stabilize around 28 and around 1 amp input. In the previous video I showed this motor part of this setup running on 18 volts at 300 milliamps, but it was without any load. And now the system has a load, which is this test generator setup over here. There's no cogging effect from my coil because it's an air core coil. As you can see, I give it a little spin and it keeps spinning. So in total the complete system is using 28 watts to run itself and to get me 2800 RPM on this rotor, which is pretty good. Let me start the system. Going for speed 1. The coil this time has more tape on it because the bobbin is made of different pieces, and exactly in the center it is glued and taped together. But I think that part has come loose now, so the bobbins start to slide away from each other, start to flex away. So I had to tape it in the length direction and like this also to hold it in place. It is speeding up. Let me go for second speed. I am going to do a AC test first with 1 watt light bulb AC. Then I'm going to do a 9 watt load with these 9 LEDs lights over here. They're all 9 are in parallel. Then I'm going to short the AC output. I'm also going to do an RPM test. Then I'm going to put the output from the coil to the transformer, to the rectifier, to the meter panel over here, to a 0.6 watt load and a 5 watt load. And also I'm going to charge this large capacitor over here. Yeah, now you can see it. It's a high performance 1 farad automotive capacitor, and it has on top of it a digital voltmeter and 2 LEDs. So this part only is using around 20 or 30 milliamps, but I will do that as last. Going on for third speed, which is overdrive. It is spinning up. The generator is making a sound like a small jet turbine. I don't know why, but it's funny. Give it some time to get up to speed. Let me check the RPM now. 2577 and climbing. Give it some time to reach its maximum speed, otherwise it will be a faulty test video. Give you a complete view of the setup. Let me go to this meter over here also. As you can see, it is now at 28 volts, just a little bit above 1 amp. A complete view from this side. It is still running pretty smooth. 28 watts for this complete setup is not bad at all. including all those pulleys and belts, so it's not bad. Let me check the RPM. Yeah, 2785, 86, almost there. Let me tweak the input a little bit, so it's exactly 28 volts. Yeah, that's about right. That's why I have a DC to DC converter. 28 volts, oops. Yeah, just a little bit more. A little bit more. Yeah. A little bit less. Yeah, let's leave it like that. Okay. Let's check the RPM one more time. Is it stable or pretty stable? 2787. Remember that RPM. 2787. Gonna connect the 1 watt load. You can see it. It's pretty bright. Let's check the RPM. 2788. Still the same. 2789. Yeah, it's a good start. It's stable. It's climbing just a little bit. Now I'm gonna go for the 9 watt load. Now I can really use a lap assistant to help me out here. Okay, you can see the 9 watt load is on. Let's check the RPM. As you can see, it's above 2800 now, so it's climbing. So the more energy out of the coil, the better. And the input is now 28, 27.9 at just below 1 amp. Gonna show you guys a total darkness test. That's the light I'm getting from the 9 watt LEDs. Yeah, it's not bad. Let's check the RPM one more time. $28 and $19. Now I'm gonna short the coil completely without shocking myself. It was 28.19. Coil is completely shorted. It is now 28.41 and climbing, so yep, it's good. Gonna unshort the coil. Gonna connect one side to the transformer. The other one I'm gonna wait a little bit for the system to drop back down to under 2800 RPM. Then when I connect this one, this DC load over here, this 0.6 watt will light up. Let's check the RPM. $27.94. Okay, remember that. Connecting the system. 6.8 volt DC at 100 milliamp. There's a light. And what about the RPM now? 28.045 and climbing, slowly climbing. So it's a good Draw gas and test again. Let me show you that in the dark. That's a 0.6 watt. Nice. Let's check the RPM again. 2810. Input is 28 volts, roughly at just below 1 amp. RPM was 2810. Now I'm going to connect the 5 watt load. 5 watt load is connected and it's burning just a little bit at 140 milliamps. Let's check the RPM. RPM is now 28, 29, 28, 30. So yeah, more power out the coil, the better the performance of the coil. And the system is still 28 at, yeah, it's a little bit less than before. So the generator, this one coil, is helping the motor side, which is always good. Now I'm gonna measure the RPM again to see where we're at. 28.43. Now I'm gonna short the DC side. It is shorted. Measure the RPM again. 28, 51, 52 and climbing. So yeah, another good test. I'm measuring the RPM at the rotor itself. It's completely black and I have a piece of reflective tape on it. That's the best way. Now I'm going to disconnect it here. The system will now go down to below 2800 RPM. And meanwhile, I'm going to connect this large capacitor over here. That's one lead. And that's the other lead, okay. The voltmeter here only works when it reaches 10 volt DC. But on this one begins to work from 2.5 and above. So whatever voltage you see here is the same that is in the capacitor. Let's do a RPM test. $27.91. Remember that, 27.91. Connecting the load. Now the capacitor is being filled. You can see the voltage here. And the two small LEDs, blue ones, are coming on and it's saying low voltage. And here the RPM is 28.13. The moment this capacitor reaches around 10 volt or more, the RPM will start to drop again. The reason for that is very simple, because there's less energy being pulled out of the coil at that point. Maybe you can see it already. It was 28.13 and now it is 28.3. You see that? The reason for this is that the capacitor is now at 11 volts already and climbing. So there's less current being pulled out of the coil, and the system is still at 27.9 or 28 at just below 1 amp. I'm gonna show you one more time. I'm gonna disconnect it here. I'm going to short the capacitor. Yeah, there's plenty of energy in there. It's a massive 1 farad capacitor. Connect it again. It's completely empty now. It's not connected yet. Measuring the RPM. 2786. Connecting it. 28, 3, 4, and climbing. 2810, almost 10, and the capacitor is being filled. And input is still the same, 27.9, 28 at just below 1 amp. Gonna let it till it fills the capacitor. Gonna show it in the dark. This is the capacitor, and that's the meters panel, the same voltage. Okay. The output of the coil now is a little bit lower, but I have magnets and plans for a new rotor, so I can boost that output a little bit more, just like before. Now I'm going to put this back on the 9-watt LED load. Capacitor now is disconnected. As you can see, there's nothing over here on the transformer, and there's still some energy in there. This meter here and this meter here will eventually drain all the energy in the system. Let's measure the RPM. 2913, 14 with a 9-watt load. Gonna do one more time a unloaded test. Actually, the coil is open. Give you a complete view of the system. Let's measure the RPM for the last time. 2791. It just went to 90. 2789. Connecting the 9-watt load. It is very important to do AC and DC tests. Not only DC and not only AC. 2805 and climbing. And also do not do only a shorting test. It doesn't say anything. Put a real load on the coil. You must let the current flow. At this side there's only 3.6 volt in the cap. This is the light I'm getting in the dark. Okay, I think I showed and say anything I have to show and say about this coil. There will be 2 more videos on high speed testing. I have shown previously 4 videos on low speed testing, but I'm only going to show 3 on high speed. 3 of the 3 coils that I think that are the best. System is still running, yeah, just below 28 watts in total, which is pretty good, but I can get it a little bit more efficient. I haven't fully tuned it yet, so plan is to make a better rotor for this coil here with larger magnets. That will make the rotor a little bit larger and also increase the input. But on the other side of the coin, Now I can only put 12 coils on each side, but then I can put 24 on each side, and trust me, there's a big difference. The difference in output will be far more than the difference in input, because the rotor won't be too big, just a little bit larger. Anyway, I think I said more than enough now. One last look at it from that side, one last look from this side. Gonna shut the system completely off. No input, it's still spinning away. There's no cogging effect because there's no core. Of course there's a little bit of air drag and that's such things, but nothing spectacular to worry about. System is slowly slowing down. I want to say no input, lights are still going. Another video in a few days.